In this lesson, we are going to learn on the derivative of exponential functions. Exponential function is a special function. If we differentiate e to the power of x, we will still get the same function e to the power of x. That is d over dx, ex is equal to dx. However, if we differentiate e to the power of fx, the differentiation will follow the rules for differentiation for ex, but we need to replace x with fx and multiply with f prime x. And we are going to write it as differentiation for e powers of fx is equal to e to the power of fx times with f prime x. In this example, we want to find the dy dx for e to the powers of x powers of 4. E to the powers of x powers of 4 is in the form of e to the powers of fx, where fx is equal to x powers of 4. Differentiate e powers of x, fx, we will get as e powers of fx multiplied with f prime x. Here, the fx, as we mentioned here, x is x powers of 4 and the f prime x is equal to 4x cubic. So thus, we will get the dy dx as e to the powers of x powers of 4 multiplied with 4x cubic, or we write it as 4x cubic multiplied with e powers of x powers of 4. Okay, let's say we have y is equal to e powers of 4x plus sine x. So if you look at this one, okay, y, it is in the family of e powers of fx. Okay, so in general, the y, it is in the family of e powers of fx. And if we differentiate that, okay, based on the previous slide, we get e powers of fx multiply with f prime x. Alright. And if you look at here, so we have fx. What is fx here? Alright, what is the fx here? Alright, so fx, if you look at, it is this one. Alright, so fx now, okay, we look at the fx. Fx, if you look at it, is the 4x plus sine x. Alright, sorry. Alright, so fx is 4x plus sine x. Okay, it comes from the powers of exponent. Alright, so this is the fx. Alright, so f prime x, if you look at here, okay, if you look at here, we have formula f prime x, so we need to find that one. What is the f prime x? We differentiate this one, so we get it as 4 plus cos x. So this is differentiation for fx. Okay, so now we are going to find the dy dx. So we did our dy dx. Okay, so we take it is from this one, because in general the function in terms of e powers of x, so we have this one, so we need to use that formula. So therefore the dy dx would be e powers of fx, okay, 4x plus sine x and multiply with 4 plus cos x. That is the f prime x. So if we rearrange that, we get 4 plus cos x multiply with e powers of 4x plus sine x. So that is the dy dx for this function. Okay, next example, let's say we have y is equal to e powers of x squared cos x. Alright, so similarly, okay, the y, it is in terms of family of e powers of fx. Okay, where the dy dx, okay, if we write the formula e powers of fx multiply with f prime x. Okay, so now if you look at here, alright, so we want to find what is the fx. So the fx, if you look at here, okay, e powers of fx, so the fx would be this one. So the fx would be, alright, x squared cos x. Alright, so we need to find the f prime x. So if you look at this one, fx, it is a product between x squared and cos x. So therefore, we need to find the u, v, u prime and v prime. So here, u is x squared, the v is cos x, differentiate u prime, we get 2x. Okay, v prime, we get negative sine x. Differentiate cos x, we get negative sine x. Alright, so therefore the f prime x, okay, we write the formula u v prime plus v u prime. So we get it as u is x squared negative sine x plus, okay, what is the u cos x multiply with 2x. Alright, so if we rearrange that, we can write it as negative x squared sine x plus 2x cos x. So that is the f prime. Okay, our solution not complete yet, okay, because we just find the f prime x, okay, not the dy dx. So now we are going to find the dy dx. Okay, so if you look at here, in general we are going to solve this one. So this is the formula that we're going to use. All right, so this is the formula that we're going to use. All right, so dy dx will be e powers of fx. What is the fx? Fx is x squared cos x. All right, and the f prime x is that the things that we have find just now. Okay, this is the f prime x. All right, so we substitute that one, so we will get it as negative x squared sine x plus 2x cos x. All right, so we rearrange that. Okay, we have negative x squared sine x plus 2x cos x multiply with e powers of x squared cos x. Okay, so if you look at that one, so this one we have we can take out the factor for x here because both have x. So if we take out the x, so at last we get here x negative x sine x plus 2 cos x e powers of x squared cos x. So that will be the dy dx for this case. Okay, let's say now we have y is equal to e powers of x over x plus 2. All right, so if we look at here, okay, y, it is in the family of e powers of fx, okay, where we get the dy dx as, all right, e powers of fx multiply with f prime x. All right, so what is the fx here? All right, if you look at this one, this is your fx. All right, that will be the fx. All right, so fx is x over x plus 2. All right, so if you look at this one, the fx, it is in terms of quotient form, quotient rule. So we need to use the quotient rule to find the f prime x. So we have u is x and the v is x plus 2. All right, the u prime is 1 and v prime is 1. Okay, next we want to find the differentiation for product quotient rule. V u prime, write the formula minus u v prime divided by v squared. Okay, don't forget we will write it when we solve question related to product rule or quotient rule. We need to write the formula itself. All right, so if we substitute the value, we get it as v is x plus 2 multiplied by 1 minus x times 1 divided by, sorry, this is something wrong. Alright, so we have v is x plus 2 multiplied by 1 minus u is x multiplied by 1 divided by v squared x plus 2 squared. Alright, so if we simplify the numerator, we have x plus 2 minus x, so we get 2 over x plus 2 squared. Alright, so this will be the f prime x. So now we are going to find the dy dx. So the dy dx, okay, so we take the formula from here. Alright, so this would be the dy dx, our dy dx. So it become here e powers of x over x plus 2 and multiply with 2 over x plus 2 squared. Alright, so towards the end we will write it as 2 over x plus 2 squared e powers of x over x plus 2. Alright, so this would be the dy dx for this question. In this example, we want to find the dy dx for y is equal to x squared times e powers of cos x. Y is actually a product of x squared and e to the powers of cos x. In general, y is a product between u and v, where the u is equal to x squared and v is equal to e to the power of cos x. If we differentiate u, we get 2x. If we differentiate v by using the chain rule in the green figure, we will get as e powers of cos x times negative sine x. And after that, by using the product rule formula for differentiation, we get the formula for product rule as uv prime plus vu prime. And after that, we are going to substitute the u, v, u prime and v prime in the formula, and we get ui dx is equal to x squared times with e cos x times with negative sine x plus e cos x times 2x. And by simplification, at last we get dy dx is equal to x e powers of cos x multiplied with negative x sine x plus 2. Okay, next example. Okay, let's say we have y is equal to e powers of 2x divided by x minus 1. Alright, so if you look at this question, it is in the forms of u over v. Okay, in general, it is in the form of quotient rule. So here, first we need to find the u. Okay, u in this case is, sorry, right here. Alright, so the u would be, u is equal to e powers of 2x, and the v is equal to x minus 1. And the u prime, differentiate the exponent, we get e powers of 2x times 2, or we write it as 2e 2x, and the v prime is equal to 1. Alright, now we find the dy dx. Okay, since the question, it is in general, it is in the form of quotient rule, so therefore the dy dx should be in the formula for quotient rule. So we have v u prime minus u v prime divided by v squared. Alright, so if we substitute the value, we get v is x minus 1 multiplied with 2e 2x minus e 2x times 1 divided by x minus 1 squared. So if we expand the numerator, we get 2x e 2x minus 2e 2x minus e 2x divided by x minus 1 squared. Alright, so if you look at here, if we negative 2e 2x minus e 2x, it become negative 3e 2x, so we can write it as 2x e 2x minus 3e 2x divided by x minus 1 squared. And if you look at here, both have the factor e powers of 2x, so we can take out the factor e powers of 2x, so we get e powers of 2x, 2x minus 3, okay, divided by x minus 1 squared. Okay, so this is the dy dx for this question. Okay, here are some of the questions related to exponential derivative of exponential function. You can try the question. We will discuss it the next lesson. You can try it at home. Okay, that's all for today.